Hello, everyone. My name is Karina Castillo. I am an MS in Environmental and Occupational Health student at the CUNY School of Public Health. I'm a second-year student hoping to graduate in December. So over the summer, I worked on carcinogens and electronic cigarette vapors. So as we all may already know, smoking is the largest preventable cause of mortality and morbidity, with 10% of these deaths being due to secondhand smoke exposures. We also know that there's toxic chemicals in tobacco smoke. These chemicals include tar, aldehydes, nitrosamines, aromatic and polynuclear aromatic hydrocarbons. So this is why in the past 10 years, electronic cigarettes have been introduced as a smoking cessation device. So electronic cigarettes deliver nicotine without the harmful byproducts of tobacco combustion. So what are electronic cigarettes? Electronic cigarettes are electronic nicotine delivery systems. If you could see in the picture, those are a few different kinds that they have in the market. So what does it do? It evaporates nicotine by heating the solution. It's called e-liquids. And these e-liquids also contain other compounds such as propylene glycol and glycerin and flavorings, preservatives, along with the nicotine. So these vapors that are generated only are generated when they're activated, when the person is smoking it, so it reduces secondhand exposure potentials. So market growth and regulations. So global sales increased about approximately 3 times between 2014 and 2017, and it is expected to grow about 5 times by 2023. The 2017 National Youth Tobacco Survey says that 1 in 5 high school students and 1 in 18 middle school students will be using electronic cigarettes, and the FDA has deferred regulatory action for 2022. But recently, FDA took steps in regulating and disallowing the sale of flavored nicotine solutions. So heating byproducts. So heating of e-liquid generates vapors, such as particles, and these particles can be fine and ultrafine. Additionally, there could be thermal decomposition of e-liquid ingredients that can form radicals that induce oxidative stress, smaller carbonyl compounds such as aldehydes, which are carcinogenic, larger aromatic compounds through polymerization. These include aromatic hydrocarbons that are also carcinogenic, nitrosamines, which are carcinogenic, and also heavy metals through the breakup of the heating element, so that would be the electronic cigarette itself. So it's just a little chemistry background. To your left is propylene glycol and glycerol, which are the 2 main components in these e-liquids. And so when you take away water from heating it, it can form these compounds, aromatic compounds such as benzene, toluene, that are carcinogenic. So there's some knowledge gaps. So there are currently 466 brands and over 7,000 flavors for which the composition is unknown and is changing, it's growing. And they're prepackaged and custom made at vape stores. So this also leads to some uncertainties. And there's also incomplete characterization of e-vapors. So this lack of exposure characterization leads to insufficient risk assessment. So the objective of our study and the aims included to assess exposure to harmful and carcinogenic compounds in e-vapors formed during the heating of the e-liquids. And we had an emphasis on benzoalpha-pyrene, which is BAP, and benzene. So our first aim was to generate e-vapors from pure compounds and solutions. The second aim was to collect e-vapors in the aerosol and gas phase, and the third aim was to have perform a chemical analysis for benzoalpha-pyrene and benzene. So to the left, you'll see what we aimed to do, what we planned to do, and then what we completed. So we were able to generate those vapors in pure compound solutions and 43 commercial e-liquids. This was done at the University of Alabama at Birmingham, the Rouse School of Public Health. We were also able to collect e-vapors in the aerosol and gas phases, and from that we were able to measure particle size distribution of the e-vapor, and the third aim was to perform a chemical analysis for benzoalpha-pyrene and benzene. So from this we're able to link pure compounds to available e-liquids. That's supposed to say benzoalpha-pyrene partitioning to particles, and we were able to kind of assess if particles carry other potentially harmful products. So here's a little diagram of like what we did. Here's the, I don't know if anyone's ever seen what kind of an electronic cigarette looks like. This is the device. Right here would be the screen. It has a whole bunch of different modes and settings you can put it on to either increase the heating of it or the strength. Right here is the e-liquid chamber and the heating tank. So there's a coil in here that's where the heating actually takes place. So we connected this device to a dilution chamber that had two ports. So one would be to measure benzene and benzalpha-pyrene. That's through charcoal tubes right here. And then the other one is to measure the particle size distribution, and that's connected to this machine right here, and that's a sampling pump. So pure compounds and solutions. So the chart here kind of shows these are 16 different formulations that we did. So we measured each component in its pure form, and then we did it in solutions that are readily available in the market. So we created these mixtures, and then these numbers are coming from percentages based on the evolution of e-liquid composition. And we also use nicotine in free form, which is commercially available through most commercial e-liquid companies, but there's a limitation to that because, as many of you know, there's the Juul that has just recently come out, and they use nicotine salts instead of nicotine in its free form. And I hypothesize that they use nicotine salts because it delivers the nicotine more effectively than nicotine in its free form. So that's why people are kind of aiming towards the Juul now. So these are the brands that we used, their nicotine content and the flavors. So we did a lot of different flavors to test the particle size distribution on those. And this represents 96 of the US retail market, except for the Juul. So here are some of our results. So I know it's a lot, but the graph here, I just want to point out that there's low particle release for water. So water would be right here on the bottom. You can kind of follow this line right here. It's the only one that's really different than the rest up here. This just shows that like water is just one mode and that the others are bimodal distribution. So this right here is all for one puff of the e-vapor. So the first mode that you see here, which is the first curve right here, is the primary particles from heating. So that's the direct heating of the vapors. And then the second mode right here, sorry, is for the condensation from the primary vapors and secondary oxidative products. So this is indicative that the reactions, such as those that produce benzene and benzalpha-pyrene, are possible within the second mode. And then size distribution. So from here, we can kind of see that all of them, except for water here at the bottom, kind of have the same particle size distribution for all solutions, which correspond to primary emissions. We aren't able to really correspond this to secondary particle size distribution because it takes too long and we wouldn't be able to capture the sizes from that. And then from this we can this chart shows that most particles are in the respirable range, which is 0.5 to 0.6 nanometers to micrometers to 1 micrometer. So from particle mass, so there's extremely high particle mass levels. Although most of the particle mass is then exhaled out when we breathe out, even 10% of that would be extremely high. And more particles are formed from propylene glycol than glycerin. But if you look at all the solutions towards the end, there's kind of really no consistent trend between particle mass and propylene glycol and glycerin ratios. So it's relatively consistent for the formulas that we have in the market right now. And here is the last results that we have. So we tested 3 flavors of the same brand. So here you can kind of see that the 3 flavors have similar concentrations of glycerin, propylene glycol, and nicotine from the 3 different colors. But there is differences in the toluene and benzene levels concentrations for menthol, fruit, and tobacco, with tobacco actually being, what one would think would be more, but it's actually less than the menthol, and this could be, the differences may be related to chemicals being used for the flavoring. So in conclusion, high particles and number concentrations there's high particle and number concentrations in the respirable fraction that are generated by vaping, and particles are directly released due to the heating and secondary formed by condensation of primary and secondary vapors. There's secondary compounds that are possibly formed, and that benzene and toluene were formed in flavored e-liquids, which was higher for menthol than tobacco, and it may be related to what's inside the e-liquid. So future steps in long-term research to complete the analysis for benzoylpyrene and complete Joule experiments this fall at the Harvard School of Public Health, and then finalize and submit the peer-review manuscript. My long-term research goal is to link chemical composition to toxicological outcomes and in vitro systems, and then also monitor biomarkers of e-vapors and e-cigs used to exhale breath condensation, and relate it to respiratory function and systematic biomarkers. And I just wanted to take the time to acknowledge the program, Dr. Solomon, my mentor who helped me a lot throughout this, Dr. Kavoris, Dr. Democrio, Professor Jinshin, Dr. Claudio Longu, Dr. Mauricio Chabel, and Bumi Dada, which is who really helped me out at Birmingham. And yeah, that's it.